Okay, so this is mainly going to be more 8th grade review because you should have covered this in 7th grade advanced. But they're going to teach it like it's brand new. So something we talk about, especially introducing this new chapter where all types of graphs are involved, is first we have to be able to identify the slope of a graph. So the slope, technical definition, is the steepness of a line. Okay, and if we're being very particular about our definition, it is the equal to the vertical change divided by the horizontal, or in layman's terms that we're going to stress is something called rise over run. Now, one difference between how I might teach it versus how others might teach it is focusing on like the vertical change being up and down, the horizontal be changing left and right. I stress just being able to find the rise of a run and then focusing on the direction of the line, or what I know what Mrs. Brotherton refers to as the end behavior. So let's just break it down. If you look at number 1, what I tell my kids is I'm going to put my pencil on the highest dot. I'm going to draw a straight line going down, but stop when you get to the other dot and then draw an L. Now, yes, this happens to be a backwards L, but it's the same premise. Now, with that, we are going to count the sides of what we've made, which is a right triangle. And slope is quickly associated with the right triangle. So here's what I mean by that. I'm going to count how long the sides are. And when I do this, I like to use the squares that are outside the triangle so I'm not messing up. So if we count here, it's 1, 2, 3, 4, 5, 6, 7 squares there. On the horizontal side, there's 4. Now remember, we stress on the slope is rise over run. Think about which direction rise normally goes. That's like your up and down. So the rise for number 1 is 7. And then the run, think of side to side, the run of the triangle is 4. Okay, now this is where we have to check our fraction and see if we can simplify any further. Now, I don't mean change to a mixed number. We leave it improper if it's improper. But does 7 over 4 simplify further than 7 over 4? And it does not. Now, again, this is where we focus on the end behavior. So if you know your left from your right, which a lot of you still do this, look at the right arrow. So this is the left side arrow. This is the right arrow. Pay attention to which direction it's going. It's pointed upward. So that makes the slope positive 7 over 4. And there's our answer. If I completely lost you, well, let's do it again. So if I look at number 2, again, start with your pencil at the highest dot. I'm going to draw a straight line going down, but stop when you get to the other dot and draw an L. Now I'm going to count the sides of this triangle. What makes this one a little trickier is now I'm on the edge of the graph, but it's the same premise. I go 3 on this side, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 squares on that side. Again, if we stress rise over run, the side going up and down is your rise, so that's the 3. And then the run is the side to side, so 3 over 9. Now this fraction simplifies. So if you leave it over 3 over 9, then it's going to be counted wrong. You're not going to find your answer because they simplify it. 3 goes into both 3 and 9. 1/3 is what it simplifies to. But again, pay attention to the direction of the line. This is the left arrow. This is the right arrow. Since the right arrow is pointed downward, just like we kind of covered in domain and range, it is negative 1/3. And that's my slope. I'm going to go back to 3 and 4 in here in a second, but let's just reiterate all of that we just practiced. So I put my pencil on the highest dot. I draw a straight line going down, but stop when I get to the other dot and draw my L. Here I have 1, 2, 3, 4, 5 squares going that way, and 1, 2, 3 squares going side to side. Again, my rise is 5, and my run is 3, because 5 is the vertical change and 3 is the horizontal change. 5 over 3 does not simplify past 5 over 3, but the right arrow is pointed upward, so we're going to say it's positive 5/3. So far, so good. Let's keep going. Number 6, again, pencil on the highest dot. I draw a straight line going down, but stop and draw my line across. Count how long the sides are. So this one's 2 by 2. Now this one, because they're identical, doesn't matter, but rise is 2, the run is 2. Anything divided by itself is not 0, it's 1. And again, because the right arrow is pointed up, it's positive 1. So that's my answer. Number 7, if I draw a line of my L again, so highest dot to lowest dot, and I count the sides, the closer or the steeper the line, the harder it may be to count. But this is 3 and 1. Again, my rise is 3 because that's the side going vertical. And then my run is 1. That's the side going horizontal. 3 over 1 simplifies to just 3. And then if I look at my right arrow, which is this arrowhead right here, it's pointed downward. So that makes it negative 3. Let's do one more regular, and then I'm going to go back to 3 and 4. Again, we do our rise, which this case would be 4, and our run would be 5. 4 over 5 does not simplify past 4 over 5, but the right arrow is pointed upward, and that makes it positive. Now going back to number 3 and 4. If you look at number 3, when you have a flat line like that, there is no way for me to draw a triangle or a right triangle given the dots that I do have. But let's see what I can find. When I count how long the side is from this dot to this dot, that's 3 squares. Well, you tell me, is the 3 representing the rise or the run? Well, if it goes side to side, that means 3 is the run. Well, what would the rise be if there was no vertical change? Well, that would be 0. And 0 divided by anything is just 0. And 0 doesn't carry a sign, so it's not positive or negative, it's just 0. Well, let's talk about number 4. When it's a vertical line here, and I count how long the space is from dot to dot, this is also 3. But does this 3 represent the rise or the run? Well, since it's a vertical change, that's the rise. Well, what would the run be if there is no horizontal change? Well, that would be 0. But if you try to calculating this in your calculator, 3 divided by 0, it's going to give you an error. This is known as our undefined slope. So a quick little tip on how you remember. If it goes horizontal, remember 0. If it goes up and down, it's undefined. So if I look at number 9, because it's horizontal, the slope is automatically 0. If it goes up and down like number 12, then it's automatically undefined. It doesn't matter the numerical value of the rise. Well, that's honestly going to be 8th grade, where they give you the coordinates plotted. Where you have to be careful is like number 13, whenever they don't give you the points plotted. So you have to be able to take a graph and identify your own points. So what I tell my kids is you want to scan this line, and I'm looking to where the line itself crosses a corner of the squares perfectly without any gaps. So if I look at number 13, and I apologize if it's not the best zooming here. Okay, at the very corner right here, very edge, there's one that could it be. But I want you to look more specifically at this one right here. This looks like it could be a point, but if you notice, it barely misses the corner, so that can't count as a point. Well, if I keep scanning, this one looks better, and of course you want to choose the best. Again, when I scan, I look like this dot could be 1, but it doesn't hit that corner quite right. So then I continue, and then the next point would be here. Okay, and again, all I'm doing is scanning the line, and I'm looking for my own points. Well, see right here, it looks like it could be 1, but it's not, so I'm not going to identify that one as, but this one does. Now, technically, I only needed to find 2 points, because no matter where I draw my L now, I will get the same slope, something that 8th grade covers. So for instance, if I drew my L with these 2 points, or whether I draw my L with these 2 points, let's see what happens. So the rise for this one, 1, 2, 3, 4, 5, and 2. And then you count this one would be 10 and 4. And at first you're like, miss, those are 2 different fractions. Well, if I simplify, 5 over 2 is just 5 over 2. But 10 over 4 actually simplifies to 5 over 2 as well. So the simplified fractions equal each other when it comes to the slope. So no matter where my points lie, it should be identical. But because that right arrow is pointed down, that makes it a negative. Make sense? Let's try again. So number 14. Again, I'm going to scan the line to where I'm looking for points that would be through a corner perfectly. So again, this one has several to choose from, but you also want to make sure, like this one looks really close, but I wouldn't trust it necessarily. This one's much better. If you're not 100% sure whether it's a good point, then don't use it. Make sure you use ones that are really going through those corner edges. Otherwise, you'll end up with the wrong answer. Now, even though I was able to find 5 of them, again, I only need to find 2. So you don't have to stress about finding every single one. And what I'm going to look for are the rise over run. So this is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6, 7, 8 here. Again, the rise is the side going up and down. So 6 over 8, which is the run. But when I simplify that, because if you complete your answer as 6 over 8, it's going to be wrong. It simplifies to 3 over 4. The right arrow is pointed up, so that makes it positive 3 over 4. Catching on? Number 15. So I look at it. I look for my simple points here. So this one would be a good one. Oh, this one has several, actually. And if you notice the spacing between my dots, you'll notice a pattern. That's almost a giveaway, too. You have to have the same spacing for you to know that it's the same that you're on the right track. So here you see the spacing is almost identical. So again, draw your L. This one I count 4 over 2. If you count 6 over 3 or 10 over 5, because no matter what, when we simplify it, all of our answers should be equal to 2. The right arrow is pointed up, so that makes it positive 2. And it gets pretty repetitive. I'm only going to pick and choose some of these just for preference, okay? Number 16, of course, remember, if it's a vertical line that goes up and down, that is automatically an undefined slope. Just something brand new to 9th grade that you don't cover in 8th grade. If I look at number 21, when it's a horizontal line, just remember horizontal means 0 slope. So 0 is the slope. And then just going to do these last 3 for time's sake. Again, I look for my own points. And you start to notice a pattern if you get the hang of getting your own points. And I draw the L. This one would be 3 over 5. Nope, 3 over 6. I can count. And so when I do 3 over 6, it simplifies to 1 over 2. One side note that I noticed just a little bit is make sure you don't flip the slope. It's just 3 over 6, which is 1 over 2. And then since the right arrow is pointed down, it makes it negative 1/2. If I look at number 23, again, look for your own points. In this case, I found a few, but again, you only need 2. So if I see these 2, that would be 2 and 8. 2 over 8 simplifies to 1/4. And since the right arrow is pointed up, it would be positive 1/4. Just to finish up the notes here, I find my 2 points, or find 3 or 4 or 5. But no matter where I draw my points, if I count my rise over run, this one would be 4 over 1. And 4 over 1 simplifies to 4 with that right arrow pointing down, which means it's negative 4. So just to reiterate the positive and negative, if the right arrow is pointed up, it's positive. If the right arrow is pointed down, it's negative, kind of like we do with domain and range.